Hey guys, so in this video I wanted to go over Unit 3 Assessment Review. So yes, yours looks a little bit different than mine, and it's okay. It is still number 1. So for number 1 and number 2, in the first section we are factoring the GCF out. That is all we are doing. So, here it is. We want to determine if we have a GCF with the terms 6x to the third, y to the second, and 12x y to the third, and negative 36y to the second. So I'm going to do it the long way first, and then I'll do it the short way for number 2. So I'm going to expand our 6x to the third, y to the second out as far as I can. Let's do it in green. So our 6, we can separate that out as 2 and 3. Our x to the third can separate out as x times x times x. And our y squared can separate out to y times y. Now our 12x times y to the third, we can separate out as 2 and 6. And our 6 can separate out as 2 and 3. So those would be our prime numbers. Then we have x, can't expand that any. And then y to the third, y times y times y. Then our negative 36. We're going to take 36 and we're going to divide it by 2. We get 18. So the negative doesn't really matter. We only care about the 36 when we're dealing with our GCF. So 2 and 18. Then we can keep going. 2 and 9, 3 and 3. So those would be our prime numbers that we're looking at. Then our y squared, we can expand it to y times y. So the purpose of doing this way is if you can't visualize all of the factors and what the expanded form looks like. Because then you have to ask yourself, what do they have in common? Well, each of them have a 2 in common. Now, do each term have another 2 underneath them? No, because 6 does not have another 2 with it. So we only have a 2 so far. Actually, I'm going to make that a little bit smaller. So we have a 2. Now, do all of them have 1 3 at least? Yes. There's a 3 under the 6, 3 under the 12, and 3 under the 36. So we're going to have a 3 involved in our GCF. Now, do each of them have an x underneath them? No, because our negative 36y squared does not have an x. So x is not involved in our GCF. Now, do each of them have at least 1 y involved? Yes. There's 1 y under the 6, 1 y under the 12, and 1 y under the negative 36. So we're going to have a y. Now you have to ask yourself, is there another y in common? Yes. 1 y, 1 y, 1 y. So there's another y involved in our GCF. Can we get another y under each term? Is there another y in common? No, there's not another y under the 6. So this is creating our GCF. So we have 6y squared. So we're going to use this 6y squared and we're going to divide each of these terms. So our factor form is going to have our GCF out front and in parentheses, and we're going to take each of these and divide it by our GCF. So let's do it in blue. We had 6x to the third y squared divided by our 6y squared. The 6's cancel out. The y's cancel out. Left with x to the third. Then we had 12x to the first. Go ahead and put that 1 there if you have difficulties with the understood exponents. Y to the third over 6y squared. So 12 divided by 6 is 2. There is not an x in the denominator, so just the x comes out by itself. And then we have y to the 3 minus 2 because we're dividing. So that simplifies to positive 2x times y to the first. We don't have to put the first. And then lastly, we have negative 36y squared divided by our 6y squared. Negative 36 divided by 6 is negative 6, and the y's cancel out. So I'm left with negative 6. So subtract 6. So that would be my factored form for number 1. For number 2. Number 2, hopefully, we can look at the number 2, 4, and 24 and determine that our GCF is going to involve a 2. And then the shortcut to look at the variables is we have a b. Do all of them have b's? Yes. What is the smallest exponent of b in this expression? 2. So we're going to have b squared in our GCF. Now, does each term have a p? Yes, each term has a p. The smallest exponent of p in this expression is 1. So in our GCF, we're just going to have p. Now, do each of our terms have a w? No. Our first and our third does not have a w, so we do not include it in our GCF. So our GCF is going to come out front, and then we're going to factor this out. Let's do purple. So I have negative 2b third times p over 2b squared times p. So negative 2 divided by 2 gives me negative 1. My b to the 3 minus 2 because we're dividing, and my p's cancel out. So in my factored form, I have negative, and I don't have to put the 1 because multiplying by that 1 does not matter. I do need that negative. And then 3 minus 2 is 1, don't have to put it. Then we have 4b to the third times p times y, or w, divided by our GCF. We get 4 divided by 2, which is 2. Again, we have our b to the 3 minus 2. P's cancel out, and then we have that lonely w that's included because there's not a w in the denominator to affect it. So we have positive 2 times b times y. Lastly, we have 24b squared times p squared divided by our 2b squared, which is our GCF, equals 24 divided by 2 is 12. Our b's cancel out. We're left with p to the 2 minus 1. Or 12 times p raised to the 2 minus 1 because of the understood 1 in the exponent, and we're dividing. So in our factored form, we have positive 12p. And that creates our factored form for number 2. All right. So the next section is factoring when a equals 1. So if a equals 1, then we can go straight into our big X method. If a doesn't equal 1, then we have to either slide or divide, take out a GCF, do whatever. So 1's pretty simple, so let's do 2. For number 2, our a does not equal 1. So is there a GCF involved? Hopefully you can see it. Yes. There's 3, 9, and 12. So the GCF is 3. So we're going to take out our 3. And we're going to do 3x squared divided by 3, which is x squared. 9x divided by 3 is positive 3x. And negative 12 divided by 3 is negative 4. Now does our a, and what do I mean by a? I mean, when we look at the standard form, y equals ax squared plus bx plus c. Our a is always our coefficient of x squared. Our understood 1 tells us our a is 1, so we can go straight into our big X method. We do not have to slide and divide in this section. So my b is coming off to the left, my c is going off to the right. So 3 and negative 4. I'm creating a t-table. What times what gives me 4? Well, smallest number is 1 and 4. Can I add and subtract 1 and 4 to get to 3? Yes. 1, 4. So my question, as I'm doing this, is I want 1 times 4 to give me negative 4, and 1 plus 4 to give me 3. Which one needs to be negative to make both of these true? Well, if I make the 1 negative, negative 1 plus 4, does that give me 3? Yes. If I make this one negative, does that give me negative 4? Yes. So my answer, or my magic numbers, are negative 1, 4. So once I did my big X method, I have my GCF out front, I have the variable that I was factoring, and then I have minus 1 because it was negative, and x plus 4 because it was positive. And that is how you're factoring using the big X method. Okay. The next section, you are factoring when a does not equal 1. So let's go to the next page so you can see all of the things. So in this one,